Okay, so in the previous video, we went over overall what's a rational function, some of its property. We talked about asymptotes, talked about also we finished with the process and the steps that we take in graphing rational functions. Now, in this one, we're going to actually do a couple of examples of graphing of rational functions. Now, the ones that we are looking at today are just reciprocal of linear functions. And tomorrow, we're going to look at reciprocal of quadratic functions, and after that, we're going to look at just general rational functions and how to graph them. So as we said in the previous video, the steps, we start by finding x and y intercept, because it doesn't matter what type of function we are dealing with. That's part of the key points that we need to find. So to find the x-intercept, we know that the y is equal to 0. And we said that when y equals 0, that means your numerator needs to be equal to 0. Well, here, because in the numerator you just have 1 and there is no x there, that numerator can never be 0. So x-intercept, there are none. Y-intercept, let x equal to 0, as always. So whenever I let x equal to 0, it would be y equal to 1 over 7. So that is my y-intercept. Okay, so that's one of my important points. Another thing that we said that it's important for us is finding the location of vertical asymptote. So we said that vertical asymptote is where the function is undefined. So when the denominator is equal to 0. So to find the vertical asymptote, I said 2x plus 7 equal to 0, which makes x equal to negative 7 over 2. So that's the equation of my vertical asymptote. So you see it's a vertical line, and that's the equation for it. Now for horizontal asymptote, so that we need to sub in a number that is very large. Okay, now I'm gonna actually do the end behavior analysis a bit later in the same question, but right now I just want to figure out what my horizontal asymptote is. Now, based on those examples that we did, and at the beginning, that investigation that we had, we saw that for reciprocal of linear functions, it's always the same thing. Because if x is a very large number, say I sub in like 1,000 here, a million here, really 2 times a million we get to 2 million, right? And adding 7 really doesn't have any effect to it. So my denominator overall is going to be a very large number. What is 1 divided by a very large number? Very small number. Exact. So that very small number is really close to 0. So my horizontal asymptote is at y equal to 0, which is the x-axis. Okay? So those are important. Now, I always suggest that when you start doing graphing, as soon as you find something, put it on the graph. Okay? And at the end, you have to see that all of them basically kind of connect together and they make sense. If you see something is out of place, then you go back and you check maybe you made a mistake somewhere. Okay? So let's draw the axis here. So my y-intercept is a 1 over 7. So let's say this is, I'm going to put my scale for my y-axis as 7 units representing 1. 1, 2, 3, 4, 5, 6, and then that's the 7. So that would be my 1 unit. So 1 over 7 is here. So that's my y-intercept. Okay. But for my x scale, I can use the same thing as I had, just 1 square 1 unit. So I have negative 1, and then negative 2, negative 3, that's negative 4. So my vertical asymptote is at -7/2, which is -3.5, essentially. So let's now draw my vertical asymptote. So this is my vertical asymptote here, and we always use a dashed line for vertical asymptote. I have my y-intercept. There was no x-intercept, and I know that my horizontal asymptote is at the x-axis, which I'm not gonna put the dotted line on top of my axis. It's not needed. But even right now, knowing the general shape from my parent function and the investigation that I did, I can even draw it right now. I know how it's gonna look like. But let's to confirm it, and it's a requirement, let's go through all the steps and make sure that everything that we're gonna find here matches what we think that we should be getting. Okay. So I said that we need to find the behavior around my vertical asymptote. Now my vertical asymptote is at -7/2. So I have to look at, if I'm approaching that value, -7/2, from the right-hand side and from the left-hand side, what's happening to my function? So the way I show right-hand side and left-hand side, I show a little plus on top. That means from the right-hand side. And if I say x approaches -7/2 with a little negative sign on top, then that means they're approaching it from left-hand side. Okay? So what it means is that now I want to figure out what is my y approaches to. So what I do is that I sub in a value into my function close to -7/2. So -7/2 is -3.5. Now I'm saying from the right-hand side, that means slightly larger than -3.5. For example, -3.4. Okay? So we sub in -3.4 in the function, into the function. And I'm going to look at what is the value that I will get. So 2 times -3.4, that's -6.8. Okay? Plus 7, that's going to be positive 0.2. Okay? So positive 0.2, so 1 divided by 0.2 is going to be a large number. Okay? Now I could have, as I get closer to -3.4, -3.5, let's say I use -3.499999999, I will get a larger number. The thing is, as you approach a vertical asymptote, you always approach an infinity, because you're going to approach either a very large number or a very, very small number. So really when you sub in a value, what's important is the sign. And as you can see here, it was -6.8 plus 7, that gave me positive 0.2. And 1 is already positive, so positive number divided by positive is going to be a positive. So it's y approaching infinity. However, as x approaches -7/2 from left-hand side, so that means a number that is slightly less than -7/2. For example, -3.6. When I sub that in here, -3.6, I get -7.2 plus 7, which is -0.2 now. So a positive divided by negative is going to be a negative number, so I'm going to approach negative infinity. So this is what it means. So as I'm approaching -7/2 from right-hand side, my y value approaches positive infinity. That means my graph going to look like that. As x approaches -7/2 from the left-hand side, so from here, my y approaches negative infinity. Okay? So that's the behavior around the vertical asymptote. Now, I also need to do the end behavior. Meaning that what's happening to function as x approaches infinity, what does y approach to? And as x approaches to negative infinity, what does y approach to? Okay? So now I sub in a very large number. So if I sub in 1,000 into the function for x, it would be 2007. 1 divided by 2007, it's a very small number close to 0. But it's slightly more than 0. Okay, so because you can be a number close to 0, but it might be slightly positive or slightly negative. So that's why I'm going to say it approaches to 0, but slightly more, so I'm going to put a little plus on top. Okay, it makes sense. I knew already it was 0 because that's my horizontal asymptote. And we said that horizontal asymptote really deals with the end behavior. Now, if I sub it as x approaches to negative infinity, that means subbing a very small number, let's say negative 1,000. Okay, 2 times negative 1,000, that's negative 2,000, plus 7, that's still a negative number. You divide 1 by that, it's going to be a very small number, close to 0, but it's the sign of it is negative. So it's less than 0. So that's why I'm going to put 0 and negative here. And I'm going to put that information on the graph. So as x approaches to infinity, so over here, as x approaches to infinity, your y approaches 0, slightly positive, and as x approaches to negative infinity, you're approaching y from 0 from the negative side, from like slightly less. So now I have all the information that I need. So I'm just going to connect these together. So make sure that I go, oops, that did not go through my y-intercept. Going to make sure that everything goes through. Okay. So that's how my graph looks like. The question also asks for the domain and range. Well, my domain is every real number other than my basically vertical asymptote. So it would be from negative infinity to negative 7 over 2, and from negative 7 over 2 to positive infinity. Or I could write it, if I want to write in set notation, I can say x is the element of R, and x cannot be negative 7 over 2. So in this case, like if I don't ask you specifically for interval notation, maybe writing in set notation is a bit easier. Now my range is all real numbers, and it cannot be just 0. So it's just below 0 and greater than 0. So again, I can say y is the element of real numbers, and y cannot be equal to 0. Okay? So this is the steps that we take in graphing. So pause the video, go over the solution, make sure you know how to do it. Also do part B yourselves, and then come back and check the solution for part B. Okay, so pause the video. Okay, so for the second one, you see we need to find again y-intercept and x-intercept. So if x is 0, that would be 3 over 2. So my y-intercept is at 3 over 2 or 1.5. So I'm just going to go, as I said before, I'm just going to, as soon as you find something, I'm going to plot it on the graph. So my y-intercept is at 1.5. So that's my y-intercept. And x-intercept, again, there is none, because if y is equal to 0, this fraction can never be equal to 0, because its numerator is 3, can never be 0. Now, my vertical asymptote is where my denominator is 0, so it's at 2 minus x equal to 0, so x is equal to 2. And for horizontal asymptote, as I said, if you sum in a very large number, you are dividing 3 by a very large number, or a very, very small number, like negative 1 million, and then you will get close to 0. So y equal to 0 is my horizontal asymptote. So let's put my asymptote, so x equal to 2. And make sure you draw using your ruler. Okay. So that's my horizontal asymptote. Now I need to do my behavior around the asymptote and end behavior. So as x approaches to 2 from the right hand side, so that means a number that is very close to 2 but slightly more than 2. For example, 2.1. I have 2 minus 2.1. That's going to be a negative number. 3 divided by negative number is going to be a negative answer. So that's why I get negative infinity here, as you can see. So as x approaches 2 from the right hand side, as we are approaching 2 from right hand side, my graph gonna approach negative infinity. Now, as we are approaching x from the 2 from the left hand side, so here, as we are approaching 2 from left hand side, that means the number slightly less than 2, for example 1.9. If I sub in 1.9 into my function, it's 2 minus 1.9 is just 0.1. 3 divided by 0.1 is going to be a positive number. So that's why I get positive infinity here. So on this side, I'm going to go to positive infinity. Okay? So that's my behavior on the asymptote, vertical asymptote. Now my end behavior as x, which I showed it in green, as x approaches to infinity. I know I already approached 0, but let's see how I get 0 slightly less than 0. Because if I sum in 1,000 here, 2 minus 1,000 is going to be a negative number. 3 divided by negative is going to be a negative value. So even though it's very small, it's going to be close to 0, but it has a negative sign to it. So therefore, I put 0 from below. So 0 negative means from below. So that means I'm approaching it like this, which makes sense because these two need to match up with each other. Okay. Similarly, as x approaches to negative infinity, let's say if I sub in negative 1,000, it would be 2 minus negative 1,000, which would be 2 plus 1,000, so that's 1,002. 3 divided by 1,002, yes, it's close to 0, but it's slightly more than 0, so that's why I'm approaching it from above. So it's going to look like this. So again, everything is done. I just need to make a connection here, going through my y-intercept, and that's my graph. Okay, and here's my domain and range. So x cannot be equal to 2, and y cannot be equal to 0, and every other value is valid in this question. Okay, so we also ask you to try C and D yourselves, and we will take them up tomorrow in class. Okay, good night.